I've decided to make videos on calculus, and the goal of this video is to get you comfortable with the word limits. Entire calculus is built upon the idea of the limit of a function, and therefore we start at limits and then proceed to more advanced topics such as differentiation, integration, and DE, differential equations. Let's take a look at this function. f of x equals x squared minus 4 all over x minus 2. Not very scary, right? A simple rational function. If I say find f of 1, you would probably immediately say 3, which is correct. But if I say find f of 2, can you find the answer? Try it now. When you plug 2 in place of x, the numerator becomes 4 minus 4, which is 0, and the denominator becomes 2 minus 2, which is also 0. Now I hope that you did not cancel these zeros out and say that the answer is 1, because you cannot perform such an operation. 0 over 0 is an undefined entity. Well, technically it is one of the indeterminate forms, but we'll worry about that later. So f of 2 is undefined, and that is where algebra stops. But here in calculus, we ask what is happening around f of 2. Let's try to find that by looking at its graph. The first thing that may have surprised some of you is that it is a straight line, even though the function is a rational function. So what's going on? Well, don't sweat too much about it because some rational functions reduce to linear equations. For now, I want you to focus on the graph, and you may have noticed this ring or hole over here. It shows that the function does not have a value at x equals 2. It simply reinforces the idea that f of 2 is undefined. Remember that I'm showing you this graph because we are interested in the behavior of the function around x equals 2, and when I say around x equals 2, I mean very close to x equals 2. Let's just eyeball this for now. This is x equals 2, where f of 2 is undefined. But what do you think the value would be around here? Something like 3.99 maybe? And now let's go to the right side. Here maybe the value is 4.001. Remember, we're just eyeballing this for now. But you may be a bit skeptic and want the actual numbers. Here's a table that I created. As the value of x gets closer and closer to 2, the value of the function gets closer and closer to 4. The same happens from both the sides. If you're still doubtful, you can take a number that is very close to 2, like this or this, plug these into the function, and the value should be very close to 4. With some approximation, we could say that as x approaches 2, the value of the function approaches 4, while remembering that at x equals 2, the value of the function is undefined. This is what a limit is, the behavior of a function very close to a given point. In fact, this statement is the most important statement in this video, and so I am going to repeat it. Limit is the behavior of a function very close to a given point. Now that we have an intuitive understanding of limits, let's use mathematical symbols. Limit of the function as x tends to 2. You will see this symbol a lot. This stands for x tends to 2. Some people say x approaches 2, which is totally fine. This entire expression is basically the mathematical way of asking what this function is approaching as x approaches 2. We already know that the function approaches 4 because we used the graph, but how do we solve this without the graph? Recognize that x squared minus 4 is essentially x squared minus 2 squared, which can be rewritten as x plus 2 times x minus 2. Now you have x minus 2 in the numerator and in the denominator, so you can cancel it, right? Tread very carefully while doing such cancellations, especially in calculus. Remember that if this binomial is equal to 0, then you have 0 over 0, in which case you cannot cancel it. So we need to ensure that this is not equal to 0, and how do we do that? Since we know that x is approaching 2, that means x is very close to 2 but not equal to 2. Which in turn means x minus 2 is very close to 0 but not equal to 0. Now that we have confirmed that x minus 2 is not equal to 0, we can cancel it from the numerator and denominator. We are left with x plus 2. Now apply the limit. which means plug in the value that x is approaching, which in this case is 2. Therefore, the limit of the function as x approaches 2 is 2 plus 2, which is 4. That is exactly what we concluded graphically, right? To recap, we just solved a calculus problem, first graphically to gain an intuitive understanding of limits, and then solved it systematically using proper math symbols the way one is expected to solve in an academic setting. So if you understood like more than 50%, you deserve to take a moment to celebrate. And now some food for thought. While solving mathematically, we had this step over here where our function basically simplified to x plus 2. How about you go and graph this and the original function and tell me the difference in the comment section. Don't cheat. Try to think for a couple minutes, only then should you go into the comment section to see what others have posted. By the way, there's also a hint in the video. Thank you for giving this video a thumbs up and subscribing. See you next time.